Good afternoon, everyone. My name is Artur, and I'm honored to present my dissertation at the BIM Plus conference. The topic of the work I'm going to talk about is integrated planning and recording circularity of construction materials for digital modeling. The work was conducted under supervision of the great professionals I learned a lot from, Professor Miguel Azenha and Professor José Granja. So let's get into it. The construction sector is one of the leading sources of environmental impact, since its business operations lead to raw materials depletion, environmental contamination, and greenhouse gas emissions. It is responsible for consumption of about half of extracted materials. Over the last 50 years, the extraction has extended more than 3 times. It is projected that by 2050, if no change is made, the equivalent of almost 3 planets could be required to provide the current lifestyles. The problem is that up to 85% of all retrieved resources finally become waste, and construction and demolition waste is about 30% of it. Today, its largest amount is either downcycled or being disposed on the landfills. The European Union 2020 target metric of 70% recycling rate has not yet been achieved. However, just recycling is not sufficient and can be referred as an intermediate stage towards circular economy with sustainable production and use. It was stated recently that the European Union circular economy agenda should be aligned with the digital agenda. It is claimed that circular economy is impossible without progress in digital technologies. In July this year, the new Commission report was issued, declaring that the more effort will be made toward the strong connection, twinning the green and digital transitions. But the problem is that the sector of construction, resources, and materials currently has the smallest IT expenditure. Therefore, the focus of this work was set on demolition process. But prior to understanding where and why the digital technologies can be potentially deployed, the current business process model was built to perform the gap analysis. The main drawback is that the information on supply of materials for reclamation and recycling is usually generated after the demolition is done. As it was identified, even though there are recommendations for an audit procedure, its report is not necessarily digital, making it hard to reuse in the future. The results are not widely available to build the knowledge base of demolished assets. Another gap is that the estimated quantities are dependent on the skills of an auditor and time spent on the assessment, which leads to imprecise quantification and, as a result, to reactive waste management. And during the demolition, waste managers' decision process is highly dependent on on-site management, which makes it hard to provide better outcome for products, such as reuse. To identify the potentials for IT deployment to improve the current process, several aspects were studied. In legal sources, as well as in literature, the mentioning of BIM becomes more and more frequent. In construction, demolition, waste management, BIM is the most proposed information technology. However, it has been rarely used. However, it has been rarely used for the end of life cycle. In regards to the demolition process, the obstacles refer to the absence of BIM models, to the lack of interoperable datasets, and questioned economic benefit. Therefore, the methods of effective and efficient reality capture, of information management in BIM, and interoperability aspects were studied. Since it is claimed that the market for secondary raw materials is a necessity to increase reuse and recycling rates, existing platforms and initiatives were examined with the analysis of their business models. The lack of all the marketplaces identified is descriptive human input interface. Since the web applications have been improved over time, allowing usual software to be upgraded and shifted to the websites, opportunities of BIM and web were studied to define its potentials for integration. The main purpose of the work was to perform the BIM-driven approach for demolition projects. The idea was to represent an asset as a bank of products and materials in a web-based application for open public use. To achieve the purpose, the objectives were set as to provide justified workflow information requirements for demolition audit, to set information requirements that allow the BIM model to host information for the deconstruction analysis and quantification, and to design a prototype of a web-based IFC platform enabling BIM models, validation, and analysis. Based on identified gaps and priorities, the new upgraded business process model was proposed, with a digital-driven project delivery. More appointed parties were introduced to enable BIM implementation. The suggested methodologies are: first, a cost-effective approach of data capture and modeling with scan-to-BIM workflow. Second, BIM-based project delivery with defined information requirements. And last, product data templates for interoperable information circularity. Based on review of web applications and identified potentials of BIM and web, it was proposed to use a web-based platform for IFC BIM model processing to promote publicly open and vendor-neutral solution that will create an automated input for the marketplace. Since masonry and concrete waste are dominating positions, accounting for 40 to 80% of all the waste, construction demolition waste, the certain accuracy in estimation of volume is required for the further quantification. Therefore, laser scanning with a handheld device was proposed to precisely generate assets three-dimensional representation. It was concluded that using this technique, the data capture becomes an expeditious procedure with precise enough output. Since, besides facial representation, the materials characterization is required, the template for demolition audit was elaborated based on existing guidelines. For both point cloud data and audit report, level of information need was established to provide qualitative input for BIM modeling. But before addressing the BIM modeling, we should clearly define the structure of information containers at the bottom level to support digital processes using machine-readable format. Therefore, the product data template circularity subset or group of properties was established to be used for construction demolition waste management. Since properties put in data template correspond to a specific characteristic of construction product, the search for references was made. The main sources applied were EPD, Environmental Product Declaration, Levels Framework, Guidelines for Waste Audit, and IFC domains with minor user-specific requirements that were considered as helpful in demolition planning. This developed information subset constitute alphanumeric data requirements for the level of information need. Since the framework defines the content of a BIM project deliverables, it can be applied for all subjects of information exchange. It was established for three main purposes: input for desk study, input for modeling, including both reality capture and demolition audit, and the construction analysis with the use of digital model. The major principle formulated here is that the effort invested for BIM model should not overcome the possible benefits of the work itself. For example, roof system. Defining its full geometry could require considerable time without the use of automation methods, and the benefit could be questioned. Therefore, for quantification, the elements could be described in alphanumeric datasets with values of materials weight distribution per length, area, or volume. However, it was stated that the more case studies are needed to consider other possible peculiarities. Based on the level of information need, established modeling rules, and BIM execution plan as process controls, the BIM model was created according to the purpose, demolition planning. All the elements were built using standard libraries, but with providing the requested geometry, alphanumeric information, and documents. Since the roof area and underground parts were not defined during the site visit, which is close to the real practice problems, they were not modeling complete. In future, this can be solved with parametric models, also defined as archetypes by one of the current initiatives. But the main requirements that is important here is that this data should be open to make the process efficient. Then the model was exported to IFC step file, since open data formats are aimed to provide interoperable systems, intrinsic characteristic of Industry 4.0. First, before using the platform, the model assessment was implemented in IFC Viewer. Even though sometimes the geometry information was distorted, quantities were correct, which was of high importance. It is claimed that fully interoperable systems are not possible to achieve. However, here the main task was to transfer the datasets that are required for specific purpose. Therefore, the model was checked in accordance with established level of information need. Here is the structure and process flow of developed platform for IFC file processing. After being deployed in a real-world scenario, the application could be described as a three-tier architecture. To build up the interface or front end, HTML, CSS, and JavaScript were used, allowing to represent the application on the client side in the web browser. To provide the model interpretation in the web page, the XeoKit software development kit was deployed in application tier. Analysis and validation of a BIM model were performed with the use of IFC OpenShell Python library. The library MySQL-DB was used to connect the database on the consistency layer. The CIS and JSON libraries were used to pass variables back and forth. All the programming skills were developed during this work. Here is the UML sequence diagram of the developed platform to describe the business logic. It all starts with the user registration to provide authorized access. After being logged in, the user can upload the model with documentation, namely photos of the real objects. So the system generates the unique reference number. Using this reference number, we can view and manipulate the model straight in the web browser. When the data is uploaded, we can perform validation that checks the model and gives the GUIDs of elements with issues. Also, we can ensure that the project position is correct in Google Maps, retrieved from the IFC file site properties. Here is another validation procedure. After validation, the user is asked to provide some extra information, and then the model is parsed with generational specification in an SQL table. We also could receive notification in Messenger about the database update. In total, there are 4 check-in procedures that allow user to ensure that the right input will go to the marketplace. Currently, the check for information requirements in accordance with the level of information need is performed within the scripts in application tier. However, it can potentially be improved, for example, by storing the level of information need in a more flexible way. For example, generation of JSON files that would transmit the variables in validation procedures, instead of using them directly defined within validation scripts. Therefore, basically, any information content can be checked in this way. We just need to provide the instruction of what to look for. After validation, the model was parsed into an SQL table format to make automatically retrieve specification ready to be uploaded to the marketplace, therefore representing the building as a bank of products for reuse and recycling, and avoiding descriptive human input interface problem of existing solutions. Therefore, at this work, the new business process model was proposed based on identified gaps. The point cloud data generated in an efficient way with handheld laser scanner would provide a relatively precise asset spatial representation, enabling BIM modeling with automatic quantification. To enable circularity of construction materials, information on products should also become circular, which cannot be done without standardized and interoperable product datasheets. The digital models developed for demolition and product datasheets should be available for open use to build a knowledge base and to unify the effort in creation of more sustainable future. Automatically retrieve specification, supported with a visual representation in a web-based platform, can eliminate the hindrance related to the human input interface of existing marketplaces. The developed web platform allows to provide traceable information flow and business transparency, promoting circular economy, and it serves as a base for building prediction models. And there is one more thing. It creates the basis for a digital, open, free market for construction demolition waste trade. To end up my presentation, I would like with a quote that says that the waste is worth something if people can put their mind into it. Thank you for your attention, dear organization team. I appreciate the opportunity to present my work today. Please, I'm open for